Hi future doctors, welcome to the next class. We will see one important model on fringe width. We are going to apply so many equations, which concept we came to know how to apply the concept. We can see this in this problem. Find the distance from, we have to calculate from central bright band, central point where the intensity falls to half on 1 by 4th of the maximum intensity. So first we will see half 1 by 4th, you people only can solve. So what is the intensity relation? We came to know in interference pattern. All this is going to happen in YDSS. Still above problem will be there. I didn't write the problem. So what is the problem means? It is going to be used monochromatic light of wavelength, that Young's double slit experiment apparatus they will say. Distance of the screen is capital D, distance between two slits is small d. So that one only we are going to apply. So this is the main problem, how to solve the question. So we came to know I is equal to 4 I naught cos square 5 by 2. So this is the maximum intensity 4 I naught. Now intensity should become half of this one. First we will see this half of. Then I should become 4 I naught by 2. 4 I naught is maximum here. Then 4 I naught is cos square 5 by 2. Then 4 I naught will be cancelled. So cos square 5 by 2 is equal to 1 by 2. And cos 5 by 2 is equal to 1 by root 2. Then what is cos theta? 1 by root 2 means 5 by 2 is going to be 45 degrees. Correct? Cos theta is going to be 5. So 5 is going to be 90 degrees. 90 means pi by 2 if you want to write in terms of pi, correct? 1 by root 2 means 45 only. Cos 45 is 1 by root 2. Next, now you got phase difference. What you should find? Distance from central bright band. So if this is the central bright band, so they're asking the distance somewhere intensity is going to be half of maximum intensity, 4 I naught by 2. So for this we should calculate this distance. For that we should come to know relation between path difference and phase difference. So what is that relation? Delta phi is equal to, so 2 pi by lambda into delta x. This is delta phi is equal. Then what is delta phi we got? Pi by 2. Pi by 2 is 2 pi by lambda into delta x. Therefore pi will be cancelled. So lambda by 4 equal to delta x. Now you got path difference. From this you should get distance. What is the relation between path difference and distance yn? So we came to know in YDSE path difference delta x is equal to d sin theta. Do you know this? Delta x equal to d sin theta. Now what if you got delta x? D sin theta now lambda by 4. Then what is sin theta means? Y n by d. Here n we don't know which band that is. Just we are calculating where intensity is going to become half of the maximum intensity. So if you substitute here, yn is equal to d lambda by 4 small d. So this is the option you are going to get in your question. Now you can solve another question which is half the 1 by 4th, half is completed, sorry, 1 by 4th. So for this second question you can do fastly. So 1 by 4 will be remaining. So we are going to cut the step of this one because 1 by 4, 1 by 2 means you got cos square 5 by 2, 1 by 2. So 1 by 4 means cos square 5 by 2. Then cos square 5 by 2 is 1 by 4 means cos 5 by 2 is 1 by 2. So cos theta 1 by 2 means what is theta? 5 by 2 is going to be 60 degrees. Then phi is going to be 120 degrees. So phi is 120 degrees. Then substitute in this. In terms of pi, 120 degrees. So now we got phase difference is 120 degrees. From this we have to find path difference. So what is 120 degrees? How we will write means 2 pi by 3, correct? Now delta phi is equal to 2 pi by lambda into what is delta x? We should calculate. What is delta phi? Phase difference we got 2 pi by 3. Therefore, cancel 2 pi and 2 pi. So delta x is going to be lambda by 3. Previously, how much we got? Lambda by 4. If lambda by 4 is the answer, for that lambda by 4, you multiplied with d by d. Now, for lambda by 3, we will multiply with d by d lambda by 3. So, if they give lambda small d capital D, you will get distance. Otherwise, in options, this one is going to be available. This is how to solve problem very fastly if you practice. You can do 1 by 3, 1 by 8, 2 times, 3 times like that. Then you will be getting some answers. You can cross check. Some may be divided with cos phi values, whether you are getting or not. Otherwise, it will become little bit difficult. Otherwise, they will give, let us assume if you are getting here 15 degrees, we came to know cos 15 value. Correct? So this phase difference of it is coming, that value they are going to give cos phi value. So next one in this diffraction. Some people will call diffraction. Diffraction or diffraction. What is meant by diffraction means this is also bending property of light. Bending property of light, when light travels from one medium to another medium, is refraction. Bending is happening from same medium to same medium, is nothing but diffraction. Because of change of medium, here because of obstacle or aperture. If you are saying or if you are taking any leaf or hand like this, so if you are focusing light on the hand, image of this one, shadow of this one is going to be, not image, shadow of this one is going to be forming on screen, isn't it? How much size of the object is there? Hand is there, same size of shadow you won't get. Like that leaf you can take. If you are taking hair, thin wire, if you are focusing light on that, you may not get shadow of that wire. Why? Because light is going to bend towards that sharp edge of the obstacle. That bending property of light only we are calling it as diffraction. So how it is going to be happening? So for this small aperture they are going to take or obstacle which is having size A. So one plane wavefront is going to be incidenting. So it is bending at the edges. Normally it should go like this, but it may be bending like this. Because of bending property, you will be getting redistribution of light energy on the screen. Again, same distance of the screen is capital D. Here size is going to be small a. So in Young's double slit experiment, we got two slits S1, S2 with separation D. In place of D, you will get here. Here remaining all things are going to be same. At what distance it is going to be? Maximum, minimum. What is the condition for that? For interference pattern, delta x is equal to d sin theta we got, path reference. Here also you will get same thing. Delta x equal to a sin theta. I am giving simply for you people to solve problems very easily. Here small d is distance between two sets. A is size of this obstacle or aperture they are going to say. This A sin theta. D sin theta is going to be n lambda for maximum. Here n lambda will be coming, but this is for minimum. That one you should remember. Here intensities will be same. So 2n minus 1 lambda by 2 for minimum. So here 2n minus 1 lambda by 2 will be coming for maximum. Quite opposite you are going to get. Here intensities are going to be same in YDS, interference pattern. But in diffraction pattern, intensities are going to be different. It will be decreasing. So where the first minimum is going to be coming? At which distance? So first minimum is going to be A sin theta is first minimum 1 lambda, second minimum 2 lambda. Therefore, sin theta is going to be, how we will write means there, sin theta is y by d. Here also sin theta is y by d. Y by d is equal to lambda. Y is equal to d lambda by a. This is one side. So another side you will get if you multiply with 2 times. This is the width of the central minimum, central maximum they are going to ask. Between two minimums, one maximum is going to be happen. This is only central maximum. So width of the central maximum they are going to take width of central maximum. they are going to take it as 2 lambda by a. So here it is going to be happening right side lambda by a, here it is going to be minus lambda by a. Here you will get plus or minus and lambda they will write. So this is the small change and comparison you have to remember for diffraction and interference pattern. Maximum they will ask question on this distance of central bright band. Otherwise, first minimum, second minimum, what is the position where it is going to happen, they will ask. At that time again same formula you are going to take. So yn is equal to nd lambda by a. In place of sin theta, let us assume a sin theta is going to be n lambda. So this formula is for minimum. So in place of sin theta, what we will write? Yn by d is equal to n lambda. So yn is nd lambda by a you will get. So here yn is nd lambda by small d you will get. Here nd lambda by a you will get. That small change you should remember, but here n is for minimum, here n is for maximum in interference pattern. So if you remember this is enough for diffraction if they are asking question on this.